Scaling is a word that we hear all the time. But what does it really mean to scale smarter? Today we're exploring what high-growth tech companies can teach small businesses about building for the future. Because whether you're running a massive engineering team or a two-person accounting firm, the principles of scalability apply. Joining me today, I have Malcolm Box, the GM Engineering of Xero in the UK. Malcolm has experience working in software development management at Amazon Web Services, Amazon, and numerous other companies. And he also co-founded his own company, Telebug, the world's biggest TV companion apps and scalable back-end platform for shows such as The X Factor and Got Talent. Malcolm has spent years building and managing platforms that serve thousands of users. And today he will share what that experience can teach every entrepreneur about growing without breaking what makes your business great. Thanks for joining me today.
Thanks, Alex. Nice to be here.
And awesome to be here in person as well.
Absolutely, yeah. Welcome to the UK.
Thank you. Cool. Maybe we can start with a bit of context.
Sure.
Can you tell us a bit about your role as GM of Engineering at Xero?
Yeah. So my role as GM of Engineering is broadly to look after the UK engineering team for Xero. That's about, I think it's about 80 people here in the UK. We have people working in tax, in payroll, for SIFT, so a range of different domains. But broadly, I look after the people here in the UK.
Awesome. And now that we've had a bit of a sort of formal introduction, what is something that might surprise people about you?
That's a good question. The one that tends to surprise people actually is that I like sewing. So I'm a sewer. I like to make clothes and things, despite what I'm wearing today. Yeah, and that often surprises people, but I think it comes from an engineering background. I like making things with my hands, and as well as programming and things. And it turns out that in a London flat or house, it's much easier to do sewing than it is to do woodwork or metalwork or build a boat in the backyard. So
Makes sense. You got to use the space that you have.
You've got to use what you've got. Yes, exactly.
Awesome. So if we talk about scalability, what do you think are the key ingredients that make a platform truly scalable? And how could we translate those into how small businesses could structure themselves for growth?
Yeah, great question. I mean, I think from a technical perspective, the things that really matter is how do you split the work up? How do you understand where the bottlenecks are? What's limiting you? What's the rate limiting step? Yeah, there's always something in any process. There's always the piece that is the limit, right? The one that you can't get first. In a supermarket, it's typically the checkouts, right? You can't get people through the checkouts. The queues build up at lunchtime. So how can you think about scaling that? Well, supermarkets are a great example. They parallelize it, right? You put more checkouts and then you can check out more people at once. So it's very similar for engineering, for technical systems. Just figure out how the system works, where the bottleneck is, and then how do you split that work out and parallelize it. And I think that applies to businesses, right? It applies to a supermarket. If you understand what the limiting step for customer value is in a supermarket, it's can people pay you money and get out the shop? Because who loves standing in the supermarket's checkout queue, right? No one loves that, right? So that's customer pain, critical part of the customer experience and journey and the value, and the rate limiting step. So again, how do you do that? You see a lot more automated checkouts there, right? So they bring technology in rather than hiring lots of people.
Okay.
Can I automate this with an automatic unexpected item in the bagging area? I don't know if everyone loves that phrase just as much as I do, but yeah. So I think that's very much a way you can think about scaling. Where's your bottleneck, and how do I parallelize that out? And maybe I can bring technology in to scale it out some more.
It's actually, on a personal note, that's been quite interesting for me at the supermarkets here, because in South Africa, we don't really have self-checkout.
Oh, okay. Right. Yeah.
We're still used to having a human checking everything for you.
So much nicer, isn't it? You get a little interaction and they don't say unexpected item in the bagging area, which is the bane of my life in the UK.
So it took me a while to figure out which part was the bagging area.
So, yeah, absolutely. Yeah.
Oh, but a great example. Can you share an example of a time that your team had to rethink how a system was built so that you could scale better?
Yeah, absolutely. I think probably I'll go back to my experience at Telebug. So we'd founded this company to do a live audience interaction and participation. Our first market was going to be for events. So, if you're at some conference, some business conference like XeroCon, for example, and there's someone on stage and they want to ask a question of the audience. Well, you can do show of hands, but you can do more fun things, polls and stuff. So we were going to do like Slido, if people know that product. So that's where we kind of started many years ago. And then we won a contract with Fremantle Media, who produce Britain's Got Talent. So one of the biggest in those days. It had like 10 to 15 million viewers on a Saturday night in the UK. So it was a huge thing. And we kind of looked at that and went, great. And then we went, that means there won't just be 1,000 people at XeroCon turning up. There will be millions of people turning up. And so we actually had to rebuild, in a very short period of time, we had to rebuild pretty much the whole of the back end of the system, rethink how we were going to do that. Again, a couple of key things was like, what's the limiting factor? And here it was like getting the votes in. We were going to do voting. So you've got to count the votes, right? So at some point, everyone voting has got to come to one place where you can go, there's been 5,123,621 votes for Alex. Yeah, you're through to the next round. And actually just getting all the numbers to flow to one place became the critical limiting factor. So we parallelized that out. We had lots of individual people, again, computers, but not people, but tabulating the votes, then sending their tabulations into one thing that tried to tabulate them all up. But yeah, that was a real shock to the system, was realizing we had one business that we were just not scaled to deal with technically. And I think that can often be a thing for small businesses that they grow, right? Suddenly you get the big client on board and you're like, oh, okay, now how do we solve this?
Yeah, because you can be very excited to have this new client on board, and then suddenly okay, this is either going to be a lot more work, need a lot more people, or we need to rethink how we're going to actually work this out.
Absolutely. Yeah.
When you think about scalability, what role does simplicity play?
Oh, that is a great question. I think it's essential, right? The thing with systems get bigger, and as you scale up your system, you've got more pieces running. You've got more servers, more database, like more of all the technology. But you've also typically got more code as well. So more actual software running that is more complicated. So you need to be always trying to find ways to rein in the complexity, rein in the chaos. Yeah. How do you make it as simple as it can be, but not too simple? Keep it simple is a really invaluable thing. So when we're looking at software architecture, we're often thinking about how can we split this system up into smaller pieces that have really clear, well-defined purposes that we can kind of, as humans, get our head around, rather than this giant, big thing which does 50 different things and they all interact in interesting ways. How can you think about splitting that out into, okay, this thing, to go back to my voting example, this thing just takes in the votes and counts them locally. This thing is responsible for putting those into a database. This thing is responsible for sending that out to the back to the TV broadcast, so they know what the scores are. By splitting things out into simpler pieces, you get to a point where you can, as humans, we can understand how our systems work, which is critical, because the thing about systems is they stop working sometimes. Everyone knows computer systems fail, but all sorts of systems fail. We had COVID, where the entire world economy failed for like a few years, and basic things that we expected to be able to happen could no longer happen. And when they fail, if you don't understand how they work, it's really hard to fix them. So, keeping things simple and keeping an eye on complexity really matters. And I think that applies to business processes, right? If you've got a simple process that has well-defined stages to it, and people understand how those work, and those things may be crazy things like written down, and so other people can pick them up and step in if things are going wrong. It's much better than having Brenda in the office who knows how absolutely everything works, but if Brenda isn't in for some reason, nothing works, right? So Brenda's pretty complicated. Human beings, complicated things, they can do lots of great things, but if Brenda's not there, the whole system falls apart. So how do you split Brenda up into simpler things that other people can pick up?
Yeah, I was just thinking from the perspective of, say, you have hired new people to join your team as well, and you've got to get them onboarded. They've got to learn how the system works, how to do the different things, how to do Brenda's job for when she's not there. And if only one person understands how it works and it's all very complicated and they can't explain in simple terms, how are you going to train anyone to help with that?
100%. And it's a problem we run into with engineering all the time, right? We're working with very complicated code bases. My teams are working in, with code that might have been written 10 years ago, 15 years ago, by people who are no longer here. And now they're just looking at it and going, okay, how does this work? And then the next person joins the team and you've got an enormous amount of implicit knowledge about how this thing should work that's got to be transmitted. So we're always looking at ways we can simplify that, codify it, write it down. AI is making a big difference there. AI is great at pointing at a complicated thing and saying, explain this to me like I'm a 5-year-old. And they do a great job of bringing that stuff back. So we do get cool new tools that help with that.
Yeah.
But it's still, fundamentally, we've got to get it out of one person's brain and into somebody else's brain. And that's always a hard thing to do.
But I think a very good use case of AI there as well.
Oh, 100%. It's been magical. People in the audience will have done different things, tried different things. But, I love pointing an AI tool at some complicated thing and say, just give me the summary. It's like, yes, here's the summary. It's like, great, give me more detail on that. And it becomes like a human tutor that never gets bored, never gets frustrated, never goes, oh, stupid person, I've told you that 3 times. They're great teaching aids. A friend of mine is using it to learn Hindi at the moment, and basically using ChatGPT to learn Hindi. He was very keen to do it. He's like, I'd like it to teach me like this. I want to focus on this, and this. And he basically, ChatGPT built out a complete learning course for him, and he's now the most patient possible teacher. Your pronunciation's great, but try saying a bit better like this.
Yeah, always lets you down easy.
So positive, can always be positive, even when it's all going wrong. It's doing great. That's a great question. Yeah.
So maybe away from ChatGPT for a minute,
Yeah, sure.
back to scaling. How do you build with the future in mind, especially when you don't know exactly what your customers or your users are going to need in a few years?
Yeah. Wow. Yes. So critical to what we do. The lead times for software and engineering is quite long. If we know we want something today, we might get it built in. It could be 3 months, could be 6 months, could be 12 months, depending how complicated it is. And then that thing will be in use for, you certainly hope, for several years after that. So you're definitely planning a long way ahead. I think it comes down for me to 3 things. One is the fundamentals, and this is something I learned my time at Amazon. I'm going to quote Jeff Bezos here. He says, what are the fundamental things that will always be true about your business? Customers, for Amazon, customers will always want things faster. So it'll always be true that the customer would rather than wait 2 days for it to arrive, would rather wait a day or wait an hour or wait 5 minutes. So, anything that helps you in that goal will always be valuable. I think that's a great insight. If you can find the key thing that will always be true, the fundamental. Then flexibility, right? So we don't know what the future is going to hold. The world is a very unpredictable, very chaotic place, as I think we've seen plenty over recent years. So how do you build flexibility, and how do you think about what's easy to change, making things easy to change? When we build systems as engineers, we're trying to build them in these small parts, simple parts, well understood parts that we can then kind of mix and match and put back together in different ways to solve different problems if we need to change things over time. So how do you build that flexibility in? And then foundations. What are the really critical decisions that you have to get right from day one? In engineering, it's often the data, right? What information do we really need for this thing to work, and how do we keep that data secure and private and not only accessible to the right people? If you get those pieces right, often then the flexible lets you address the fundamentals over time. But yeah, really tough, continual problem to solve.
It makes sense, though. For anything that you're building, you want to have a strong foundation in place, and then you want to be able to, where possible, have those moving pieces so that you can be flexible to respond to whatever the changes are.
Yeah, absolutely. There's a great, we talk about software architecture a lot, but I think we can learn a lot from architects. And there's this great, I'm afraid I cannot remember who said it, but he said the life of a building starts when it's built. Right? Architects think they design it and then they build it and then it's done and that's how it will be. It's not true. Buildings over their lives get changed all the time. We're sat here in a building that was probably once a warehouse or something that's been repurposed as office buildings. You look around every city, and I think that's fascinating, seeing how the shells change and then people reimagine buildings over time. Yeah, I think we can learn a lot from architects.
Yeah, definitely. And I think just in the time that I've been in London, I've seen so many of these very old buildings. And it's like, oh, back in the day, this used to serve this purpose. And now it's doing something completely different. So very good example.
Yeah.
Can you talk a bit about how automation and AI are changing the way platforms and teams can scale?
Oh, yes, absolutely. Absolute favorite topic at the moment is, scaling and AI and what we can do with that. I think there's a couple of things that are really coming in, particularly from AI. The first is that the cost of experimentation has just dropped massively. So from, if you think historically, if you wanted to try something, you had to, get an engineer to sit and write some code and, build a prototype or whatever. And that would take, time, quite a lot of time often. And so there's a limited number of experiments you can do at that point, right? If it's going to take someone a week to run one experiment, and you want to make a decision in a month, you're going to run 4 experiments tops, right? Now with AI, you can go, hey, AI, build me a prototype of this, describe it like vibe coding, describe it very high level, and voomp, a minute later you've got something. It won't be right. It wouldn't be production quality. You couldn't just ship it, but it helps you explore the ideas. So that cost of experimentation has just dropped so much. Same with marketing, right? Hey, give me 15 different ideas for my latest marketing campaign, or, hey, write 7 different versions of this press release, right? You can just experiment. So, that ability to explore different options for how we might scale or what we might do is massively changing things. And then I think the other thing in terms of change and scaling is that these tools make new things possible, right? I'm going to go back to building things again, right? Bricks, you can't build a brick structure more than about, I think it's somewhere between 5 and 7 stories tall, right? After that, the bricks just start to collapse under their own weight, and it's all, it's not going to work, which is why historically cities like London did not go very high. When you bring in concrete and steel, yeah, you can build a 5-story house in concrete and steel, but you can also build skyscrapers, right? So a completely different sort of thing becomes possible to build. And I think the same thing's happening here because it's like a new tool, a new technology. We can build things that we couldn't have built before. New processes, new ways of thinking about things. We've got infinite interns now. So like that's how I think of AI, infinite interns, right? They're not very bright. Sorry to any interns listening. They're not very experienced. They don't know what good looks like necessarily, but gosh, they work hard and they'll do lots of stuff for you. So, how do you think about using that ability to experiment, to get lots of things happening, and then building a different process that then makes sure that those things that are happening are the right things? And that's tricky, especially in, for accountants and bookkeepers, where the right answer is really important. So, yeah.
I think that's also why you always need that human in the loop who's going to check what the AI is saying, and you're not just putting whatever they've given you, like, here are all the things you should do. You're saying, no, okay, that's great, but I'm going to change that, move that, maybe this is wrong. Depending on whatever scenario it is.
It's a big thing we're seeing in engineering. It's a move from doing to reviewing. So, and that can be really hard for people. Like, that can be great, but it can also be really hard for people because often people really like the doing, and if you're someone who really likes building spreadsheets to build financial models of cash flow for your customers, then having the computer do it or the AI do it, and then you just review it can feel disempowering. If an engineer, got into engineering because they love writing code, and then now they're just more reviewing code that the AI has written. What we're seeing in engineering, and I think is really important, is the tools are better if they're driven by someone who really knows what they're doing. So if you someone who's never written code and you go, hey, AI, build me something, you end up in horrible places where it's just telling you to do things and doesn't work. But if you really understand how to do this thing, it just acts as a giant, like a chainsaw, in terms of the ability to cut through things and get it done fast. You can like, hey, build it like this. I want this, 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 and this. Boom, done. Right. No, change that. That's not quite right. Do this, do this. So much more productive and effective. But you have to know what you're doing.
Yes. I think that's maybe encouraging to hear. I know we've had a lot of discussions about AI on the podcast and in general.
Well, funny, I wouldn't have imagined that we covered.
Yeah.
But, where people are sort of worried that AI is going to be replacing them, that it's going to be doing the jobs that they love doing. But it's actually, again, about seeing it as a tool that'll maybe change the way that you're working. But you need to know what you're doing, what you want the output to be, because otherwise it could be giving you actual rubbish that it thinks is great.
100%.
But you need to know what to ask it.
You do. The more you can tell it what you want and be very structured, the better the outcomes you get. And that can let you get all that boring stuff that, the grunt work to just get to a point where you can do the really exciting bit just done much faster. So, hey, I've got to pick an example. I'll pick an engineering example. I really interested to build a tool that will help my teams or help me keep a broader view over the delivery that's happening in my team. It's a live problem we're literally dealing with at the moment, right? So teams are writing status reports and things, and but I want to keep an eye over a fairly large surface area, understand where there's challenges, where I can dive in to help. I might have traditionally done that in a spreadsheet and had people put things in a spreadsheet or send me emails. Now we can do it in a different way and have, build a system that just very quickly build a system that pulls all that data together, gives me a dashboard. Now, previously I'd have spent, if I wanted to build that, I'd have spent, weeks setting up all the infrastructure and, writing the HTML to make the dashboard. And then eventually I'd have got to the interesting bit, which was how do I get the data in here and then how do I then use that and maybe, get it to surface the most exciting bits. Now I can focus right on that because it built all the other bits for me. So again, think about what the thing you really love doing is and where the really interesting, valuable pieces, maybe hopefully the bit that's both valuable and that you love doing.
Yes.
Sometimes those things aren't the same. And then get the AI to do the other bits.
And I suppose in the case where those two are not the same, it's finding new things that I'm sure all our jobs are going to change in every industry, and finding new things that you find interesting and that the AI can't yet do for you.
Yeah.
So you can save time for those.
Absolutely. And again, that just helps us scale. We're talking about scalability, right? The more you can get, these are tools, right? I think it was Steve Jobs who described computers as bicycles for the mind, right? They help you go further and faster than you could go before. AI is like, I don't know, a Ferrari for the mind. It's another leap, but you still got to steer the car. You still got to know where you're going. You still got to use that to help you scale and just get more done. And then scale the business, get more time for the fun things.
Oh, absolutely. And in terms of how you go about scaling your business, how do you think about building something for speed versus building for sustainability?
Yeah, great. I think generally, certainly my experience has been that we often naturally move a bit too slow. People are often cautious. Organizations tend to get cautious. This is how we do things around here. Ooh, but there's a risk if we change. I'm sure we've all had those kind of conversations over time and seen those things play out. So I think, obviously, there is a limit where speed becomes a risk, but often the failure mode, if you like, is that people just don't move. They don't change. They don't evolve, and then they get left behind. And competitor comes in, or the market changes, and that's really high risk, right? That's the worst risk of all, is just being left behind and then too late. Back in my career, I lived through, I used to work for Nokia, or with Nokia, building operating systems for mobile for smartphones. And Nokia was huge. It was like the biggest phone brand in the world, and it made all the money, and it was like super good at what it did. And then the iPhone and Android came in, and within 5 years, gone, collapse, right? So I've lived personally through the real risks of not changing, not living, not keeping up. So I think speed is a risk at some point. We don't want to break things, but equally not changing is a risk. And then, I think the thing I learned from Amazon is the difference between a one-way and a two-way door. I think it's a really interesting, if people haven't heard, this is a really interesting mental model. Two-way doors, easy to go through, easy to come back through. So the cost of being wrong, because change is about, changing, building things, the risk is you get it wrong, right? You do the wrong thing. If it's a two-way door, go through the door. If it's wrong, go back through the door. You don't need to be certain that it's the right door. Just go through the door, make the change, and if it doesn't work, come back out again. Easy, low cost. One-way doors, bit different, right? Once you've gone through that, you can't get back. So you need to spend more time there, dig a bit deeper, be more careful before you walk through that one. Like, cutting your prices in half, probably a one-way door. It's going to be very hard to walk that back with your customers. Having a marketing promotion for 10% off or 50% off even, which is the same thing, right? 50% off for the next week, two-way door. So, how can you turn one-way door decisions into two-way door decisions? And then how do you just go through the two-way doors really quickly?
I suppose in that scenario, two-way door is really something that you can quickly iterate and then reiterate if it doesn't work.
Exactly. You can make the change. Oh, didn't like that change. Come back again, right? Changing my desktop, my wallpaper on my computer. I don't have to think about that. I just change it. I didn't like it. Change it again.
Yeah.
Changing the wallpaper in the house. Maybe that's more of a one-way door decision. At least it's a lot more expensive to change it, but you can still change it, right?
Yeah.
Knocking down. I like building metaphors. I don't know why. Knocking down the kitchen and putting an extension on. Yeah, probably not going to undo that one. That's a one-way door decision.
Yeah, so I guess the one-way door decisions, you want to make sure that you're spending a lot of time thinking about them, considering how they might impact the future, doing a lot of research into that. And two-way doors are where you can really experiment and see what sticks.
100%. Yeah.
So, what are a few engineering style principles that small business owners could apply tomorrow to make their operations more scalable?
Oh, great question. I think we've already talked a little bit about sort of parallelizing and sort of the idea that you've got more work to do. So the best way to be able to do that is parallelizing it. So, can you identify your bottlenecks? Can you parallelize that bottleneck? Can you get to, if you've got a Brenda, can you find a way to get two Brendas so that you double your throughput, or help Brenda be more effective? Is there some tools that she could be using that helps her deal with more customers, or get through whatever Brenda's critical job is? I think there's a thing that's been around for a long time in engineering, which is really helpful when you're making changes, is sort of the idea of sort of agile teams, stand-ups, daily check-ins with everyone, where you just do quick 5 minutes. What's happening? What are my risks? What's my blockers? What do I need? Great when you're trying to evolve or change an organization or a team or deliver a project, right? A lot of this stuff has become very widely spread, but it did start in engineering, and still to these days, the power of daily check-in on what we're doing is so incredibly powerful for getting people to do stuff. I don't know about anyone else, but the prospect that I've got to stand up tomorrow morning and say what I've done, it's very motivating to get some stuff done today, and make progress and unblock each other, right? And the other thing I'd probably say is mechanisms. So this, again, it's another Amazon thing, but think, again, Jeff Bezos, good intentions don't work. So we all come to work with good intentions. We all intend to diet. We all intend to exercise. We all intend to, respond to that email from that important customer, or, whatever it might be. We are full of good intentions. Everyone comes to work with good intentions, but mechanisms make it impossible to not do the thing, right? So, what's a good example of a mechanism? Putting time in your calendar is a mechanism, right? Look at the beginning of the day with your to-do list and go, I've got 5 things to do and I've got 15 meetings happening today. I should probably put some time in that, I've got to put some time in to actually do these things. Otherwise, my good intention to do my to-do list will be completely swamped by the fact that I'm in back-to-back meetings all day. And if you get into a habit of doing that every day, it's similar to atomic habits. But you think about, what's the outcome I want? What tools or processes do I need people to do, and who do I need to do that thing? And then how do I make that happen on a consistent basis? Every week we're going to do a business review. Like a common thing we do is a business review every week, right? Where are we with our key metrics? Where are we with our engineering deliveries? Where are we with our reliability, our quality of service, our latency, our performance? And if you set up a weekly check-in on that, wow, that makes things actually happen. People, you look at those things in a way that if you don't do that, you go, oh yeah, we care about these things, but it's a good intention rather than a mechanism. So I think those are things that I use as an engineering leader to try and make sure the right things are happening. I think those would work for small businesses as well.
Yeah, absolutely. And what role does data play in scaling smarter?
Yes. Look, engineers, we love data. I'm a massive spreadsheet fan. I think spreadsheets are awesome. And if I can get some data into a spreadsheet, I'm a very happy man. I think it's critical in it helps you make decisions based on evidence. The scientific method really works. Look for data. So, coming back to those idea about bottlenecks and parallelization, getting some data about, how fast are we doing the work today, or how long is this process taking us? What are those key steps? What is the thing that takes the time? Gathering that sort of data. Or, if you're trying to improve customer satisfaction, well, do we have data on that? Do we have customer satisfaction data? Okay, what is it? What's it telling us? The thing I really like to do is think data to anecdotes. So think about customer sentiment. You can survey and get a 5-star rating, 4-star rating, 3-star rating, whatever. You get some data there. But actually really powerful can be those comments that go, yeah, I'd have given you 5 stars, except that, pick issue, right? That and often there's a lot more information in those little comments than 5 stars, 5 stars, 4 stars. Well, what's that telling me? Why was it not a 5-star? But the annoyed person's comment about, oh yeah, but the color was wrong, or but I had to wait too long on the telephone before I got to talk to you. Those are concrete things you can take. So that combination of data, are we making an aggregate difference? Is our customer satisfaction increasing? Plus those anecdotes of, these are specific things people are complaining about that really help you drive that improvement. So helps you scale up whatever you're trying to do. Are we trying to get better at serving customers? Are we trying to get faster? Are we trying to reduce our latency? Serve people faster. All of those really help getting it. So start with some data. Make sure you collect some anecdotes. If you haven't got data, there's a great book recommendation, How to Measure Absolutely Anything. And it's basically a brilliant book on, like, when people say, oh, well, we couldn't measure that. I'm like, yes, you can. And he's basically, he's got this whole list of things that people claim they can't measure, and just like examples of how you can measure it. And the simplest one is get 5 experts in it, or 3, a group of experts, people who know some stuff in the room, and ask them to guess. And their aggregate guess will be better than any individual's guess, and might be good enough, right?
Yeah.
How much is
a starting point?
It's a starting point, right? I want to build a new house. How much might this cost? Get 5 builders. They'll give you a rough guess. You go, oh, can't afford that. I'm not going to be building a house. Or, hey, that seems like it could be in budget. We should move forward, right? I can get more detail, more accuracy. I don't need to have gone out. And I made this mistake myself not very long ago, where we went to an architect and got plans drawn up, and then got builders to quote, and then they gave us the quotes, and we went, oh yeah, we can't afford that. So, had we just gone to some builders at the start and just gone, can you give us a rough idea of what this kind of project would cost? We could have saved ourselves a whole load of time and effort. Yeah.
No, I think very valuable, and also sounds like a really good book.
Oh, it's a great book. Highly recommend. Yeah, I don't know if we can do links, but I can find.
Yeah, I can add it to the absolute list. What's been your biggest personal lesson about scaling? Maybe one that surprised you?
It's always the thing that you don't think will fail that bites you. And if you haven't tested it, it's not going to work under load. when you're building a system, you have a mental model of how this system's going to behave, and where the risk's going to be, and you build the thing out and you get it up, and then hopefully you run a load test. So often with engineers, we'll just run a load test. We'll throw thousands of transactions a second, or millions, or depending on the scale you want to get to. You load it up with kind of simulated but realistic traffic, right? So and it's every single time I've ever done that, it's something that we had no idea was going to fail that goes wrong first. And you go, oh, that, okay, well, we weren't expecting that. So you go and fix that, and then you run another one. And coming back to bottlenecks, right? There's always there's always a weakest link in the chain. So some bit's always going to fail, but it's never the link you think. And you run it again, you go, no, this time I'm pretty sure it's going to be that. Oh no, it's that one. Okay. And you fix that, and then you do it again. No, this time we really spent a lot of time and energy making sure this was going to be, the scalable bit, but we think that's probably the bottleneck. No, that bit fails, and it's always weird. And if you haven't done those load tests, it will bite you. When I was working at Tullybug, we were working with, I'll spare their blushes, I won't name the broadcaster, but we were working with a broadcaster doing a big show with them, a nationwide big TV show. And they'd said, we need the customers to sign in with our sign-in system. And we're like, okay, and we will integrate with that. Fine. Have you tested that? Yeah, we've tested that. It'll be fine. Are you sure? It's going to be like millions of people in a short... No, it'll be fine. Okay. And they were our customers, so we couldn't really say, Anyway, what do you think happened on the very first show?
Did not work.
Did not work. Correct. Yes, exactly. Their login system went hard down. Our whole system couldn't work. Nobody could vote because they couldn't log in, so they couldn't vote. Lots of disgruntled people. And we sat there the next morning going, don't want to say we told you so, but we kind of told you so. But, you were the customer and you knew best, and customers do not always know best. So that was that, if you haven't tested it, it's not going to work. So, if you are scaling something up, trying to get more done, test it.
Yes.
Get 50 customers to phone your switchboard at the same time, or 50 friends if you haven't got 50 customers yet, and see how Brenda, or the new Brenda, handles the incoming flood of requests. End of tax year, right? Like everyone, that's accountancy's peak period.
Yeah.
Can you practice an end of tax year ahead of time and see what's gonna break, especially if you're thinking about a big marketing campaign, or a big, like in the UK, we've got this thing called Making Tax Digital for income tax, MTDIT. Lots of new customers are going to be coming on board using that for the first time this April. How can we test that ahead of time? How can accountants and bookkeepers test their processes and things ahead of time? Find out what breaks, because it won't be the thing you expect.
Oh, very good advice. I think always better to be proactive where you can be rather than reactive, and to test everything.
If you can, yes. And it's hard, right? I mean, it's hard to simulate thousands of people, millions of people doing stuff. But you can get a long way. Funnily enough, often the things break at way lower. You're designing for, when we were building systems at Amazon AWS, you're designing for millions of users, tens of thousands of transactions per second. You run your first load test, it breaks at 100 transactions per second. You're like, what? Oh, this thing over here, we forgot to configure right, and you fix that, and then you ramp up. So surprisingly, even little load tests will often uncover, oh yeah, no, oops, no, the phone can't actually, the phone system or the email inbox will flood if more than 5 people send, or the spam filters will trigger. It's always something you don't expect, right?
Yes.
It's hard to give an example, but yeah.
I suppose we can't test everything, but where possible,
Test something.
Yes,
Yeah, exactly.
So I think we're ready to wrap up with some rapid fire questions.
All right, okay. Fingers on buzzers.
Yeah, ready to go. You've already mentioned a book, but if you want to give another great book that you've read recently, or a podcast you've listened to, what would you?
I'll do for a podcast, and one of my favorite podcasts is the Curious Cases podcast. It's a science one. It's Hannah Fry and her co-presenter. Well, a co-presenter is just changed, so I can't remember the new guy's name actually. Science, fun, great. I love those kind of things.
So, and best piece of software can't be Xero or Sift.
Okay. Obviously, it's Xero and Sift.
Yeah.
Things. I love Things. It's a to-do list. Runs on my phone. Runs on my laptop. Vaguely keeps me organized. So Things. It's beautiful as well.
What's one valuable lesson that you've learned about building a business?
it's always the people. The people matter more than anything else. It's always a people problem. You haven't got the right people. You haven't got enough people. The people you've got are trying to leave you because they want to go off and do other things. It's always, if you can get the people right, everything else gets a lot easier. So hire the right people.
Yeah, really interesting in the context of a discussion about having the right processes and the role of AI. The people are still
100% the heart of everything. Yeah.
And if someone wasn't really paying attention to our podcast today,
Oh, heartbroken.
They zoned out at some point, or they were caught up in traffic.
Yeah.
And they could only take away one key message. What would you want it to be?
Ooh, yeah. No, we've talked about so many things. There's loads here. I think probably, dare I say, AI. AI has made new things possible. If you're not experimenting with it, try it. Try what it can do for you and think about how you apply it, because it is going to help lots of things scale that maybe have historically not scaled very well, and change the parameters of what's hard and what's easy. So, when you're thinking about scaling, do try new tools and make sure you test whatever you're scaling or trying to scale. That would be the other thing. Yeah, sorry, two things. Use some AI tools and then test what you've tried to build, because it will break in unexpected ways.
Brilliant. Thanks so much, Malcolm.
Thank you, Alex. It's been great talking to you.
Likewise. And thank you for everyone who's been watching or listening.
Thank you.
Thanks for tuning in to the Beyond Insights podcast. Please like and subscribe on whatever platform you're listening to right now. And please share with any of your colleagues or friends or family members that you think might benefit from listening to this podcast. That's all from us. Until next time, see you then.